So yeah, first of all, thanks for picking one of the 4 Azure sessions running at the same time. Appreciate that. It's not an easy choice. So obviously the session's only 20 minutes, so everything we're going to talk about in here is, it's not conceptual, but there's just no time to demo at all. It's just too tight to demo. So I can happily answer questions as we're going through about how it's actually done, rather than what we talk about on the slides. It is entirely possible. It's not a high level, you could be doing this with these technologies. It is actually actively done. Reason for this session, I guess, first and foremost, is Microsoft's story on DevSecOps is kind of getting to where it needs to be, but there's still quite a lot of folks, and I guess partly the reason you're here is that not a lot of people talk about how you can do these things on Azure as a platform. So we'll go into some of that detail and also talk about how to build a DevSecOps team as well, hopefully. If we have time, we can overrun a little bit. So I guess if you're a Twitter user, you want to follow me on Twitter, handles down there. But apart from that, I'm the head of DevOps at a company called Transparency, just down the road in Bournemouth, just around Bournemouth, and I'm also an MVP in Azure as well as MCT. So we basically do most of this stuff day to day, so it's quite a nice subject for me to talk about. There's lots of real world stuff we can relate it to, so that's good. And of course, thank you to all of the sponsors that I won't name out. It's obviously a lot there. But sorry. There's obviously a lot of stuff that goes into today. I'm also the track lead for Azure as well. There's a lot of stuff that goes into today that just wouldn't be possible without all of these people on here. So yeah, big thank you to them. So I want to talk about 3 core concepts of DevSecOps first, mainly just to try and level set the expectation of what it actually is and how it kind of differs from DevOps. Obviously the word DevOps has been around for quite some time now, and it is really all around aligning the core. Sorry, no worries. No worries. Yeah, it is all around making sure that obviously, so it's really development teams, your operations teams are collaborating and working better together. DevSecOps as a term, personally I actually don't like the term. I kind of think you should just be doing security anyway, so it kind of feels a bit of a marketing term really, as far as I'm concerned, to stick security around it. But fundamentally, security wraps around everything we do with DevOps, because it can be easily forgotten. And I've seen that at a number of organisations where they do DevOps and a breach happens. Best case in point in recent history is obviously the poor folks over at SolarWinds who had a supply chain attack. About 4 weeks, I think I read, after they finished their release automation pipelines, and that's exactly what was attacked. Someone injected rogue code into their application, their rogue pipelines built it and signed it, and it went out as a valid update, even though it had malware in it. So lesson there is point 1, shift left. Nice link into that. And it's really around making sure that it's everyone's responsibility, right? Whether you're a developer, whether you're in operations, a support role, a business role, it's everyone's responsibility to highlight security problems, risks, and issues. And the whole concept is really making sure that we can catch those things as far to the left as possible. And we'll talk a little bit about how we do that shortly. But in the development world, we do that in the source control repository. That's the furthest point left we can go. Next bit's around building confidence. So you all know about things like NuGet, Chocolatey, Maven, all the different package repositories. They're all third-party libraries, and there's a lot of open source components in a lot of those as well. Microsoft's massive plethora of packages that they have as part of the .NET library. There's a lot of open source code in there. You know, Newtonsoft is a great example for its JSON parsing that is open source, and it has a lot of stuff within there. And it's used within lots of different Microsoft packages. But how do we trust it? How do we know we can trust the code that's in there? So DevSecOps and the processes that go around DevSecOps are all around building confidence in your supply chain, ultimately, and making sure that the products you have at the end is something that you can trust and ship out as a product or to your customers, whatever that might be. The next one's about bringing and delivering on a secure platform. So I've used Kubernetes as an example in AKS because it's a nice logical flow through for every single step. But you could remove that, and you could insert VMs if you really wanted to in that process. You could even do it with other PaaS services, what doesn't really matter. It's just a nice logical flow through here as well. But if you think of Azure as a platform, being able to leverage the extensive set of services that Microsoft have on the platform in terms of security. I didn't notice until I was looking at some information just last week actually, that Microsoft spend 4 times as much on security than their nearest software rival in terms of size. They spend nearly $80 billion on security a year, which is an eye-watering sum of money, but it obviously works to a degree. So, what goes into a DevSecOps team, and what functions, and what do we expect people to do? So, in smaller organisations, you're absolutely not going to see 4 separate teams. You might even do one team. You might even not do all of them, but the ones that you really should be doing are security, engineering, and compliance. Operations is a nice thing to have, but you will find engineering often do a lot of that if the company is too small. And in larger organisations, you will find that this is a separate team, and these two are specific areas in the run. So security engineering is all around being able to experiment, automate, and run testing against what software you want to ship. So security engineering. So security engineering are the ones that are responsible for really battle testing what the developers have written. The developers are responsible for, I guess, base level security, making sure they're not committing secrets to the code, making sure they're not writing vulnerabilities into the code, and we can scan for those sorts of things, which we'll talk about in a minute. But it's the security engineering team that are effectively your company's white hat hackers and effectively really trying to break what you break. Security operations, fairly self-explanatory. Hopefully a SOC, I guess, is what we would call it, a Security Operations Center. So they're responsible for monitoring as well as detecting, hunting down from various different sources of information and then containing the impact. Sometimes in security they call it containing the blast radius, like in the military terminology. And when it comes to security and that line of thinking, it's actually really important to go into contain mode if you've been in a breach. A lot of companies get bad press for closing down when they've had a security breach, but the reality is that they're actually trying to contain what's happened, both from a media perspective and internally, because at the end of the day, their business is massively at stake. Again, great example, week before last. Obviously, there was a massive breach reported of Twitch, huge in fact, and Amazon owned Twitch, and of the 6,000 Git repositories that were stolen over 6 months, like they were in there for 6 months apparently, because of their relationship with Amazon, there's rumours, like unconfirmed rumours, that the source code for EC2, Amazon's VM service, was also stolen. As well as storage buckets, as well as S3. Now I have seen plenty online that say, that'd probably make it more secure, people having the source code to S3, because it's quite easy to get into anyway and quite insecure by default, but it just goes to show that the blast radius there is huge, because there's not been that proper diligence in terms of making sure stuff's separate. that's a really big thing in security, making sure everything is separate, environmental segregation, corporate segregation, and I do feel sorry for the people that were responding to that, because it can't have been, and still won't be, a nice place to work. Some quite sensitive data was leaked. Compliance operations, so who at work has to do annual security training so that they can report back as part of ISO 27001 or PCI that they've done. People are aware of policy. That's exactly what this stuff is. Like, they're the team that also, as well as reporting that compliance and train you, they're the ones that manage the response. So there's often PR and marketing teams involved to try and make it into as much of a positive as they can in these areas. In large organisations, it's kind of a given because you want to send out a corporate message. A smaller organisation doesn't really matter as much. But certainly in large organisations, compliance is something that can get them in a whole heap of hot water and trouble pretty quickly if they're not careful. And then probably the coolest area is security science. So these are the people that are learning off data that's coming in from all of the feeds that you take as an organisation. So threat intelligence, bug bounty schemes, actual hacks, community-based intelligence. They're bringing all of that together and they're learning what it means for their applications, and they're working with security engineering to forecast when they might get hacked. So I don't know if you saw last week, Microsoft defended successfully a 4.7 terabyte denial of service attack against one customer in Azure over 5 minutes, like 4 terabytes of data in 5 minutes. And the blog article from, I don't know if any of you have seen it, I should have put a link to it in actually, but it talks about how they stopped it, and it was because their security science team within the Security Operations Centre were able to forecast and detect what was happening on the customer's platform and realised that they were quite a sensitive military customer and something was happening that would have made them a target, and all of a sudden the day they focused more edge resources into protecting the edge. From 70 countries, the denial of service attack was launched against one data centre in Azure, which was North Europe. It was successfully stopped without disruption to service and no downtime. So they're obviously making quite a big thing about that, because it's the biggest against the Microsoft platform ever. Second biggest denial of service attack in all time, I think. The biggest was against AWS last year. Okay, so how can we do all of this and tie all of this together? So some tools that will look very familiar to people, but what we're going to do is going to go through, there'll be some text on there, and we can explain, okay, and yeah, this is the toilet, I'm afraid, or the bar. We'll go through and we can explain how we can tie these things together to, have a really secure process. Ultimately, that's what we're doing here. It's building a process to enable security. Okay, so secure your code, right? You'll notice from a code perspective, right? I've not put Azure DevOps in, but it's there for pipelines, right? To address the kind of elephant in the room, right? Azure DevOps is going nowhere. They are completely separate products. GitHub was most definitely a purchase from a strategic perspective, but there was actually a series of tweets the other day from someone who I don't know if they still work for Microsoft, tweeted that they were told to move all their customers off Azure DevOps because it was being deprecated. Martyn Woodward, who's the VP of Development Engineering, replied back saying, I make that decision, and I thought his wording was really good actually. It was, if that decision ever needs to be made, I'm the one that makes it, it's going nowhere. Please don't delete this tweet.
She did delete it as well.
She did delete it, yeah, afterwards, yeah.
Yeah.
So it's going nowhere. They do target very different areas. And what people actually see is that GitHub gets all of the features, but actually Azure DevOps is already a very, very mature product that's used in the enterprise. GitHub is getting there. I don't know if everyone's tried projects in GitHub, it's good, but it's certainly not boards in Azure DevOps. There's still a lot that they don't do, and it's still quite buggy, but it's getting there. And they target very different verticals as well. Like Azure DevOps is very much an enterprise tool, enterprise licensing. GitHub is mostly open source, like most of the projects on there are open source. So one of the things I will say is if you have a large focus on security, then the security features on repositories are a lot better in GitHub than they are in Azure DevOps. But you can still use GitHub and connect it to Azure DevOps very successfully. It's just a different repository source, and it doesn't make any difference to what you can and can't do. You can still get full end-to-end visibility. It's just a different repository. It's effectively like using Bitbucket instead of Git repos. Although definitely don't use Bitbucket. So there's a feature in GitHub's advanced security offering called CodeQL and Dependabot. And what these do is they identify, and if you want to, they can automatically remediate problems with dependencies. And they also do some automatic updates to them as well. So if you upload a package that if you upload some code that uses an old version of a package, it will automatically update it for you in your code. In case the developers forgot to do it, unless there are breaking changes identified in the description, and then it won't do it. It'll block the commit and make you go verify it yourself. The secret scanning is amazing. I think there's over 50,000 types of secrets it will discover via AI. The same AI technology that empowers Copilot that GitHub just launched. So it will actually tell you what type of secret it is. So I've tried this with a few customers and tried it myself. Sure enough, if you put a SAS token for a storage account in a variable and commit it, it says found an Azure storage SAS token, block commit, fix it. So straight away, talk about shift left, just linking it back to that a second. Already, we're directly making sure that we give the developers the power to go fix these things so that we don't build the code with that vulnerability in. So we're letting developers go fix that. Next thing is around continuous integration and delivery. So this is where Azure Pipelines really comes into its own. I've been an advocate of Azure Pipelines for a long time. I think the technology in there is really, really good. So in my day job, I have the solution that I look after has 40 separate containers, and they're all built using pipelines. And the full traceability comes where the execution of your pipeline is linked to a commit to the repository. So what that basically means is when that linkage happens and it says this pipeline was executed on this commit, it means that you can see all the way through to Azure Container Registry here, and the image that was built, what work items it was resolving, what bugs it fixed, what commits were in there as well, so you can then roll back from there and build the image to a previous version again. And that's for every image that you build. And you can obviously keep as much history as you want in Azure Container Registry and roll back to previous image versions really easily using Kubernetes. Security scanning as well. So a lot of people don't know that Azure Security Center does this. It's not in the free version, unfortunately, you have to pay for it. But whenever you upload an image to Azure Container Registry, it will run a Qualys vulnerability scan as part of the product, and it will publish the results in Azure Security Center. And it will tell you which ones are highlighted in there. It's backfired a couple of times for the .NET images because they've included vulnerabilities, unfortunately, but it's good because it highlights that there's a problem and it links through to the MITRE ID, tell you what the actual attack vector is. So you can make a judgment call yourself, I guess, and say whether this is something I'm okay to accept or whether it's something you want to roll back and sort out. Obviously, AKS is a service, so I was talking about this to one of the upper MVPs yesterday and today. Actually about the Kubernetes exam that you can take from the CMCF, and how it's actually really hard for someone who uses AKS to do, because 90% of the commands you don't need to use because this is a service. Whereas if you're running Kubernetes yourself, you do need to know how to use kubeadmin, not kubeadm, whereas I've never used kubeadm on AKS because you actually can't run it. It's blocked, you don't need to. But you can use things like infrastructure as code and Azure policy to secure that as a service and as a platform itself, which adds another level of security to it as well. And then on top of that, you obviously start managing your secrets in Key Vault. So this is kind of one of the most important things really. So what I actually get developers on my team to do is, if they get errors back here, that they found secrets, then actually they just need to be added to Key Vault, and a reference to Key Vault needs to be added in instead. And as long as we're getting that value from Key Vault, then that satisfies that requirement. So that's all that really matters about them. Next one's around governing authentication. So Azure AD, not particularly exciting in the grand scheme of things. It's what underwrites most of Azure anyway. But you can integrate with Azure AD, you can use multi-factor authentication, and you can use some of the activity reporting in there to identify impossible travel times, to prevent logins, that kind of stuff. For me, in the application I write, it's a multi-tenanted SaaS application, so our customers can sign up to it. It uses Azure AD. Customer manages the authentication because it's their tenancy, effectively. They just need to disable that person's AD account if they leave and they don't get access. They don't need to go back and start reworking stuff or anything like that. So it's a really great solution. Last but not least, we can use Azure Monitor and Azure App Insights that's linked into there to monitor both your application and your infrastructure in, it says real time, but near real time. So we use this as part of our release process. So after the release happens, when the container starts up, it has a readiness probe as part of Kubernetes, so it won't serve traffic until it's marked as ready. As part of that, we're sending telemetry and testing the setup of some of the services through dependency injection in .NET to make sure that they start up properly. And if that happens, great. If it doesn't and it logs exceptions in App Insights, then we automatically roll back to the previous version and stop serving traffic and roll back to the previous replica set in Kubernetes. So we can do that with quality gates to make sure that we're only releasing code that we trust and B actually works, preventing downtime. So just to kind of link back to this a second. So I used to work for Virgin Atlantic and I had 6 teams under me that were practicing DevSecOps. And these are actually stats from those teams, but where we had teams that focused on that level of testing and detection and measurement, we measured over 6 months, 30% fewer defects in production. So it doesn't sound like a lot, but those defects could have been service outages that affected customer experience and a number of other things. MTTR, mean time to resolution, so we're measuring DevOps generally instead of SLAs. So it's basically the average time it takes to recover from an outage. In the teams that were practicing this methodology and shifting stuff left, we had an MTTR that was 5 times faster than other teams. And that's because so much was understood by so many people about the platform rather than it being knowledge that was insular to a few people. Lots of people knew lots about the platform and the application, so lots of people could contribute. And also, because we're fixing stuff earlier before it leaks into production, we're not seeing those defects come into production, so it is quicker to recover from problems. And our CI/CD success was 98%. And why is that number so high? Because when we're running pipelines and we have quality gates in that search for code analysis and various other different pieces, they fail. So when we put it in for the first time, it was down to 20% because there was all kinds of stuff it was finding. But as we trained the teams and people got used to the new processes, it ended up settling about 95, 98% in between there. So much better because we were capturing everything before it went out, and as they were getting used to it, they were doing it instinctively rather than committing the code and the pipeline failing. They were committing stuff and writing it the right way so that we didn't pick up on any of those things. Okay, so just with that, only a couple of minutes over, obviously feel free to leave some feedback. Don't forget the charity quiz tonight for breast cancer research, I think, which is at 7 o'clock in the ballroom downstairs. And then there's also sponsor drinks at 5:30, right about when it's meant to start raining, all the way over there. So yeah, but yeah, apart from that, thanks for coming along and hope you enjoy the rest of the day.